everyone, my name is Amanpreet Kaur. I am for Electrical Engineering Polytechnic Department in RIMT University. So, today my topic is Semiconductor Diodes. So, before we start the Semiconductor Diodes, some basic terms we should know, that are current, voltage and resistance. So, what is current? Current is just a rate of flow of charge through a material, or we can say in a conductor. Okay. So, flow of charge, the charge may be electron, proton, right, means positive or negatively charged, that depends, because mostly metals or in conductors current is flow because of flow of electrons. And next is the voltage. So, voltage is just we can say a potential difference between 2 points in the circuit. And potential difference, what is potential difference, or we can say what is potential? Potential is just a positive and negative charged body, that depends that electron supplied by that body or they accept or donate the electron, that depends upon that positively charged body or negatively charged body. So, it is a potential difference between 2 points. So, potential difference, if there are two bodies like they have a different potential, they are a different potential, and when we connected them with the conductor, then electrons flow from higher potential to lower potential side. So, that we call a potential difference between 2 points, that is voltage. And resistance is just a property of a material that opposes the current, or we can say, because any material, any solids that, or we can say conductor, that is made up of number of tiny atoms, and because of that atoms there is electron, free electrons, some atoms have less electrons, some has more free electrons, and that gives a resistance, or we can say that opposes the flow of current. As we can say, number of electrons less, then current flow less, obviously. So, that have a more resistance. If number of free electrons are maximum, or we can say are more as compared to other, so there is less resistance, because current flow more as the number of free electrons more. So, we can say these three are connected with each other. Current, amount of current in the circuit, that depends upon the amount of voltage, and resistance, amount of voltage and amount of resistance that opposes the current flow. Okay. So, next is, you can see this picture, and obviously you can see this picture also. In this picture there is, we can say that the amount of current that depends upon the amount of voltage, and resistance which controls the flow of current, or we can say which opposes the current flow. Okay. So, next is, you can also see this picture and understand these three terms, that when we supply the voltage to the, and there is a potential difference between the conductor, and electrons flow, and we get the output in the bulb, that is the form of light energy. And you also can see second picture, that is voltage is just a motivating to the charge flow. And next, resistance, as that resistance that depends upon the length of material and also diameter, length of conductor and the diameter of that conductor. So, as the diameter increases, less resistance and current flows more, and if diameter is less and more resistance, current flow less. You can see this picture. So, next is second, this should also you know about the engineering materials, because there is a solid materials that contains a tiny number of atoms or molecules that are arranged in a such a pattern that we can say arrange in a periodic manner, we can crystalline structure. So, those solids which are in crystalline structure, we can, those have a crystalline structure, that are metals and semiconductors. But those, there are some other also solid material which do not have a crystalline structure, like they are non-crystalline structure, like insulators, like you can also like insulators like wood, rubber, these type. So, engineering materials, that we can say solid materials, that are subdivided into three parts, that is conductor, insulators and semiconductors. So, conductors, there is conductors who are good conductor of electricity, who can flow, those material who can pass the current, and their example like silver, gold, copper, steel, sea water, those are sea water like in the impure form. So, these are good conductor of electricity, they can flow current. And another is it's had a property that positive temperature coefficient of resistance. As it means as we increase the temperature, resistance of conductor increases. It means the conductivity of conductor decreases while increasing the temperature. So, next is insulator. Insulators are bad conductor of electricity, they cannot allow a current. So, rubber, glass, oil, diamond, dry wood, these are. So, these are those materials we can say amorphous solid which do not have a crystalline structure, non-crystalline structure which have. So, next is the semiconductors. So, semiconductors, its conductivity lies between insulators and conductors. Conductivity means that those materials which can allow a current. So, semiconductors which those materials whose conductivity lies between conductors and insulators. Its property is that negative temperature of coefficient of resistance. It means we increases the temperature, resistance decreases. It means when we increase the temperature of a semiconductor, its resistance goes decreases, mean it can pass a more electricity as we increase the temperature. We can say allow the current as we increase the temperature. It becomes a good conductor when we increasing the temperature. So, semiconductor have some other qualities also, very interesting quality, that is when we adding impurities in semiconductor material, we can say some other particular substances or material in semiconductor, then also we can increase the conductivity of semiconductors. So, there are examples of semiconductors that is in the pure form germanium, silicon and selenium. So, before we start this, that is atomic structure. So, atomic structure that includes two parts, that have a two part that contains, that is nucleus and we can say extranuclear part. So, nucleus is what? Nucleus have two particles, that is proton and neutron, except hydrogen. Except hydrogen, all atoms have a nucleus that contains a proton and neutron. And the second part, that is extranuclear part, that is in which electron revolve around the nucleus with fixed amount of energy. So, electrons that distributed in the shell, that maximum electrons contain the shell, that is we can say a orbit, that is extranuclear part, we also say that shell or orbit, or we can say that next to the nucleus, that is innermost shell, and that as go far away, electron loosely to the attached to the nucleus. So, electrons, maximum electrons can be in the orbit, that is with the formula 2 into n this square. So, 2 into n raised to power 2. So, it means n is what is the number of orbit, or we can say a number shell or the number of orbit, right. If we have to find out the how many electrons in the innermost shell, that is first shell, that is 2 raised into n this square, n is equals to 1. So, first shell that contains 2 electrons, and the second we just put the value n is equals to 2, that contains 8, and then 18, then 32. These are in this formula we just say maximum number of electrons in the orbit. We can find by using this formula, that 2 raised to power n this square. So, silicon and germanium, because we are studying a semiconductor diode. So, we just take the example, I just take the example of silicon and germanium. Its outermost shell has a 4 electron, because this is the fourth group of a periodic table, has 4 electron which is loosely held, and the electrons present in the outermost shell, that we call a valence electron, which takes part in the conduction. So, next is the energy band. Energy band, that energy which possesses by the electron of same orbit in the solid material. So, there are three types of bands, conduction band, forbidden energy gap, that is also in between the conduction band and valence band, and next is the valence band, that band gap is the forbidden energy gap. So, valence band is the energy possessed of valence electron, that is valence electron outermost shell, net energy possessed by those electron, that is valence band, and these are valence electron that can move, and we can that are loosely held to the nucleus of the atom. And conduction band is that band in which band, that is that energy band that possesses by the free electron. free electron, because valence band that possesses energy valence electrons, and in the conduction band that is energy possessed by the free electron, those free electrons which take parts in the conduction. Okay. And so you can differentiate between insulator, semiconductor and conductor by using the energy bands. That energy gap in between the conduction band and valence band in insulator is very large. It needs a more energy, so it is not possible, but in semiconductor there is an energy gap is less in conduction band and valence band. So this gap is we can cover by applying a energy, by applying a temperature, by applying by using a doping. Doping is what? Adding impurities. So doping is what? By adding impurities in semiconductor, that is called doping. So this band gap can be covered. So forbidden energy gap is what? Forbidden energy gap is that minimum energy required to lift the electrons from valence band to conduction band. So here is little bit energy is required to lift the electron from valence band to conduction band, and there is no forbidden energy gap between the conduction band and valence band in case of conductors. Okay. So next is semiconductor. So this we know, we already discussed about the semiconductor, what is semiconductors, their examples, all things. So first is there are two types of intrinsic and extrinsic semiconductor, and extrinsic semiconductor is further divided into two types, that is p type and n type. Intrinsic semiconductor, that is in the pure form like silicon, germanium and selenium, purest form, and they have a little conductivity, and this is uncontrollable, and this conductivity depends only on the temperature. And next is extrinsic semiconductor, when we adding the impurities in the intrinsic semiconductor, that becomes extrinsic semiconductor. So we can say it's in impure form, and we added the impurity in this, and its conductivity increasing by adding impurities, and this conductivity is controllable, and that depends upon amount of impurity added. How much amount of impurity added, that depends, conductivity depend on this. So extrinsic semiconductor p type and n type. So p type adding impurity, p type and semiconductor, that divided by which type of impurity we added. We added impurity from group third, that is called acceptor impurities. So added impurities from group third in the periodic table, that for example that is boron, barium, aluminium and gallium. These are the examples of third group in the periodic table. So we can say it acceptor impurities. Why we say it acceptor impurities? Because these impurities accept the electron from the pure semiconductor. When we added in the intrinsic semiconductor impurities of boron like barium in the third group of a periodic table, then impurities accept the electron. So that semiconductor donate the electron, that's why it's a p type of semiconductor, okay, which gives the electron that have a positive charge, which takes the electron that have a negative charge, that, okay. So that's why it's a p type, just it easy to remember. So there is no need to ratification, just easy to remember that p type semiconductor is that semiconductor donate the electron to the impurity. So that's why we call it that those impurities acceptor impurities, and p type is, so we added the acceptor impurities and third group, and examples of third group, that is boron, barium, aluminium and gallium, okay. So n type is the impurities that added from group fifth. We added the impurities of group fifth in the periodic table, and these are the donor impurities. So donor impurities, because these impurities donate the electron to the pure semiconductor, that's why we call it as the n type semiconductor. An example of fifth group, that is antimony, bismuth, arsenic, okay. So next is how do electron hole pair generate and recombine. Then you can understand while from this picture, while watching this picture, that when we adding the impurities, okay. So like a third group, they have a 3 electron in outermost shell, and semiconductor 4 outermost shell, electrons 4 electron in the outermost shell. So third group that takes the electron from the semiconductor, so that's why we call it acceptor impurities, and they leaves behind a hole. So they generate a hole. So like this we can say a hole is generated, an electron move and attract towards another hole to the free space. So it leaves the behind hole. So with the help of this you can understand intrinsic semiconductor and extrinsic semiconductor how the hole and electron pair is generate, okay. So, next is there are two types of current in semiconductor, one is drift current and second one is diffusion current. So, drift current, what is the difference between these two currents? Drift current is because of when we apply a battery, then movement of electron is increases, they are randomly move and fastly move. So, that movement is drift, and because of that movement current produced, that is drift current, and diffusion current is produced because of concentration, higher concentration to lower concentration, electrons move from higher concentration to lower concentration side. So, that because of that movement of electrons or charged particles, we can say charge carriers. So, because of that current produced, that is diffusion current. So, okay, diffusion current is produced without applying the battery, and drift current produced because of applying battery. Okay. So, semiconductor diode finally. So, you can understand the symbol of this and also component appearance. You can understand our positive side is which side is positive and which side is negative, and also component, there is a bar that is negative side and on the left side of bar that is positive side. So, you can understand the schematic symbol and real component appearance, and also p-n junction representation, there is depletion region, and there my left side is p type semiconductor and here is n type semiconductor. We join this, so there exists a depletion region. So, what is depletion region? When in the beginning of movement of the holes and we can understand holes and electrons, p type has a majority carrier of holes and n type has a majority carrier of electrons. Okay. So, holes and electrons, p side holes and n side electrons. So, in p type semiconductor, when we join, they attract towards its opposite charge carrier, right. So, holes when move towards the n side, and after entering in the n side, they recombine with electron. So, when they recombine with electron, we can say hole diffuses, and electrons after entering in the p side, immediately they recombine with holes, and we can say electron diffuse and neutralize, electron neutralize and leaves the positive ion on n region which are unneutralized, and negative ions leaves after recombine diffusion, they leaves the negative ions on p region. Okay. So, negative ion, you can see negative ions in p region and positive ions in n region. Because of their recombined diffusion, the depleted electron and holes are depleted near the junction. So, they produce a depletion region. Okay. So, this is depletion region. So, combining of electrons and holes depletes the holes in the p region and in the electrons in n region near the junction. So, this is depletion region. Okay. So, next is the potential barrier. So, that fixed ions and positive in p region and n region, that is generate a potential barrier. Okay. So, that generate a potential barrier, there is a negative side is negative exists on the potential barrier, that is in negative side in the p region and positive in the n region. So, potential develops due to presence of the fixed positive ions on n side and negative on the p side of the junction. So, because of these barrier, it is really hard for the holes and electrons to cross this junction. So, depletion layer that increases depletion layer thick and thin, that depends upon the amount of doping. Okay. So, as we increasing the doping, depletion layer thin, and magnitude of potential barrier, that it depend upon the thickness of depletion layer. So, thickness of depletion layer in thicker, more thicker, greater is the potential barrier, more energy required for mobile charge carrier to pass the junction. So, only those carrier can cross this junction without forward bias, which have sufficient thermal of photo energy. Okay. Thermal, or we can say a photo energy. So, next is biases in diodes. So, we also understand what is depletion layer and what is potential barrier. So, because of these. Okay. So, now there exists a potential barrier and depletion layer. So, electrons and holes movement stops, then we apply a battery to the p-n junction, and we can say we apply a diode battery. So, when we connected a positive terminal of battery to the p side and negative terminal of battery to the N side, then this is called as a forward bias. So, because of this depletion layer goes thin and movement begins of electrons and holes, and then obviously if movement of electrons begins, then current flow. So, with this it work as a closed switch. Semiconductor diode work as a closed switch when it is in the forward bias. And in the reverse bias, when we connected the, what is reverse bias? When we connected negative terminal of battery to the P type of semiconductor and positive terminal of battery connected to the N type of semiconductor, then what will happen? Then obviously we connected reverse, then electrons and hole repel each other. So, depletion layer thicker and current do not flow. So, it acts as a open switch. So, in reverse bias semiconductor diode act as a open switch, and in forward bias act as a closed switch. So, this is the difference between forward bias and reverse bias. Just we connected the battery, that positive to P, negative to N, and here is reverse. Okay. So, with this there is application of diode where we use the diodes. So, application of diodes, like we use application of diode, that is where we use the diodes. So, diodes used in the rectifier circuit. So, rectifier circuits is that we use the diodes, make the rectifier circuits, and that convert AC to DC, and then transformer with the center tape secondary winding, we use diodes also there, and bridge rectifier we use the 4 rectifiers and make the bridge, and also use clipper and clampers use with it, also we use the diodes. They just cut out the negative and positive portion. So, clamper is just to increase the amplitude of waveform, AC waveform. So, that increases that they takes the negative also to the positive side. So, clipper and clampers we use the diodes in these circuits, and also we use the diode to make our electronics device like photodiodes, LEDs, these types of, in these also diodes are used. So, thank you. This is all about the semiconductor diodes.